Hey college algebra. So in today's video we're going to be talking about determinants. And within this video we're going to be talking about what it looks like algebraically, what they're used for, how do we solve for them, and how we can use them to solve a system of equations. So let's get started. First I want to talk about what it looks like algebraically. Now we can represent taking the determinant of a matrix by its letter D, or something that looks like a matrix but instead of having brackets it has straight lines. So now if we wanted to take the determinant, the matrix A, B, C, D, we could just say the determinant of this matrix is just equal to D. Okay, but now the determinant, what it really matters is that it's equal to A times D minus B times C. And so if we look down here at this illustration, it shows how we come up with that with some cross multiplication. Okay, so this is key to remember. All right, so let's move on. What are determinants used for? So I know we haven't really talked about vectors or adding vectors or anything, but if we were to add two vectors, A, B, and C, D, the area between these vectors, visually, we'll have the area AD minus BC. Now I know we haven't talked about area between vectors or even really much with vector sum, but you guys should be able to add these two vectors together. Anyways, so it'd be kind of cool to show you guys that visually. Also, the determinant determines whether the system has a single solution. A system will have a single solution, determinant is non-zero. So let's do some examples right quick. Actually, before we do some examples, I want to mention some history behind determinants. The Chinese actually used determinants way back in the 3rd century BC. So they didn't have matrices back then, but they had system of equations that they had to solve. And they used determinants to determine if their system of equations would have a single solution. So anyways, let's take this determinant of this matrix A. Now to do that, all it is equal to, so we want to find the determinant, I'm sorry. So do that, you can rewrite it as 1, -1, 4, 3, where these straight lines represent we're taking the determinant. Now, multiply across, 1 times 3, -1 times 4. So 1 times 3 minus -1 times 4. Now this is equal to 3 plus 4, which equals 7. Okay, so that's our determinant. Now I asked this question, does it have a single solution? The answer to that would be yes. If we look at this previous slide, it says it has a single solution if the determinant is non-zero. And so this one is 7, which isn't 0, so the answer here is yes. Now what I mean by single solution here is that we will not, when we REF this matrix, we won't have zeros in our bottom row. But let's look at this matrix. So let's take the determinant of it. Okay, which is equal to 1 times 8 minus -2 times 4. Which is just equal to 8 plus, oops, sorry, did that wrong. Don't forget about your -4 right here. And so this will be -8, which is equal to 0. Now this one does not have a single solution. So when we REF this matrix right here, we will get zeros in the bottom row of our matrix, and by showing that there's zeros in the bottom of our matrix, we'll either get 0 solutions or infinite solutions. So taking the determinant doesn't really verify whether or not it will have 0 solutions or infinite solutions. It just verifies that it will have a single solution. Okay, so can we solve a system of equations with determinants? So I just paused the video and wrote down this system of equations. Now, I'm about to show you guys how it's possible to determine the solution by using determinants. So anyways, let's write this in an augmented matrix. Okay, now let's multiply this top by the letter d, or variable d. And just to save time, I'm also going to multiply this bottom row by b. So that our matrix will turn into the following. A times b, oops, A times d, and b times d, s times d. All right, and now we just do the same for the bottom. All right, now let's subtract the second row from the first row, so that way we can get this guy right here to be 0. Okay, so anyways, when we do that, we'll have a times d minus c times b, then b times d minus d times b, and we'll have s times d minus t times b. Okay, so now we can rewrite this new matrix as the following. Now, b times d minus d times b, those are both the same thing, so subtracting the same thing from itself, it's just 0. S times d minus t times b. Okay, and we'll finish our matrix. All right, so now this element of the matrix should look familiar to you guys. Now, let's rewrite this into a system of equations. Oops. And so we're going to, imagine that being a constant in front of x. And this is what it equals. So anyways, this is this guy's system equation. And we're just going to ignore the second rows for right now. We won't need it to solve for x. Okay. Now remember that a times d minus c times b is equal to our determinant of the matrix A, B, C, D. And this guy over here is the determinant of the matrix S, T, B, D. Okay, so now we can rewrite this matrix, right? Or we can rewrite the system of equations. So we can write it as determinant A, B, C, and D times x, which equals determinant of S, T, B, D. Now we just get x by itself. So x is equal to the determinant of this matrix here divided by, oops, nope, sorry, wrong order. Okay, so this matrix is on top, and we'll divide that by the matrix that was multiplied by x. Okay. And so we get that x is equal the determinant of that first matrix divided by the one that was multiplied by x. So now, instead of showing you guys the proof of how we can solve y for using determinants, I was going to give it to you guys. So we already solved for x right here. All we needed to do is solve for y, but anyways, here it is right here. The only difference are those top two matrices. The bottom is always going to be the determinant of your coefficients in front of your x and y. Okay, so now that we know Cramer's rule, let's go ahead and solve some systems of equations with it. Okay, so I wrote up this system of equations. Let's solve for x, y using Cramer's rule. Okay, so 2 will be our a, 1 will be our b, -1 will be our c, and 4 will be our d. And 3 will be our s, and -2 will be our t. Okay, so x is just equal to the determinant of s, b, -2, and 4. And that's all divided by our coefficients in front of our x's and y's. Okay, so if you guys are a little lost at all with where I found that top matrix, all this is our S, this will be our B, this is our T, and this is our D. And I've already labeled all of our multiples in our system. So, okay, what is this equal to? Well, we know to find a determinant, all we do is cross multiply, right? So this is going to be equal to 3 times 4 plus 1 times -2. And now we divide that by this determinant here, which would be 2 times 4 plus 1 times -1. Okay, and we can simplify this down to be 10 up top and 7 on the bottom. And so this will be our final answer since we can't reduce that anymore. Okay, so this will be equal to x. And we solved for x, right? Now all we have to do is solve for y. Okay, so what does y equal? So y is equal to this matrix right here. So we look at our system of equations. So we put a to its a spot, 3 to the s spot, -1 into the c spot, and then -2 into the t spot. All right, so now all we have to do is divide it by this matrix right here, because it's the same for both of these. Or I'm sorry, the determinant right there. Okay, so now we have two determinants and divide by each other. So this top one's just going to be equal to -2 times -2 plus 3 times -1. And we've already solved for that determinant earlier. We just got it to be 7. It's here, here. 7 being our solution. Okay, so what is this equal to? When we add up our numerator, we'll end up getting -7 over 7, which just equals -1. And that is going to equal y. All right, so we solved for our x, we solved for our y, we're good to go. Okay, now how do we find a determinant on a calculator? So if we're given this determinant right here, how can we solve it using a calculator? Now, I haven't showed you guys how to solve a 3 by 3 determinant yet because it is a lot trickier than a 2x2. But anyways, let's do it on a calculator. So to do that, we go to our matrix list. Let's go ahead and edit one of our matrices. Change this to 2, R3, and change this to 3. So we have a 3x3 matrix. Now we put in all of our elements of the matrix. Okay, so now I have all of them in my matrix. So now I'm going to go second, quit. Now let's go back to our matrix, go over to math, and look at that. Determinant is going to be our first one. Second matrix. Click the matrix that we want to find a determinant of, and solve. Isn't that something? So now the determinant of this is just equal to 0. Now remember, since it's equal to 0, is it going to be singular or non-singular? The answer is non-singular. So if we REF'd this matrix, we'd end up getting zeros in our last row. And therefore, we'd have either no solutions or infinite solutions. Okay, so that's your guys' video over determinants. There'll be questions posted on the blog for you guys to answer. I hope this video was informational over determinants, and I'll see you guys Monday.